and welcome back. So today we're going to be creating or simulating a smart patient observation system. It's a prototype healthcare monitoring solution that is designed to demonstrate how embedded systems and connected technologies can be used to support patient observation, improve response times, and enhance healthcare delivery, right? So the system is going to be using Arduino Uno, which is a microcontroller, right, to collect information from different sensors, which represents common conditions that is within a patient care environment. So this sensor's reading will be displayed at the end of the day on a dashboard, which we're going to build later, which allows healthcare personnel such as nurses or whoever it's going to be taking care of this patient to monitor the patient's conditions remotely. So this is what we're creating today, all right? And we're building the embedded system, and at the end of the day, we're going to also build a dashboard, and we're going to see how we're going to use this to communicate. So to communicate together, all right? So this is what we're doing today. So first, we already have our Arduino Uno, which is right here. Now, I mentioned that some of the sensors that will be needed, and I'm going to explain why I add up the sensors. We're going to need LED, and the LED represents the patient status indicator. So it indicates the status of the patient, right? Whether the patient's health status is okay. So we're going to change this to a green LED, right? And another thing, of course, for our LED, we need a resistor, which is the 220 ohms. So I'm going to change it to 220 ohms, so that's to help with my resistor. So let's just reduce this, zoom out, so that we could have a very good simulation. So this is this. This time around, I'm going to be connecting my resistor to the ground, which is the cathode of the LED. That's what I'm going to do. So I'm going to do this connection right here. And the other end of the resistor would go to ground, which is the GND, to create a balance. I like to change this color to color black, so it indicates that this is for this is ground or earth, or yes. So for the positive, which is the anode, I'm going to be connecting this to digital pin 8. So digital pin 8. Yes, so I'm going to do this to digital pin 8. So this is connected to digital pin 8. So like I said, this represents our patient status indicator. And another thing that we're going to use for the patient indicator, which is the status of the patient, is a buzzer. So if the condition of the patient is not very okay, it makes a beeping sound. It would be like there's something like the life of the patient is being endangered, or the healthcare personnel has checked and there's something going on. So remotely, a healthcare personnel, without being right there, can actually see, this is something wrong, the BP is high, or there's something not very okay. So the buzzer makes a beeping sound. So the black, we're going to connect this to ground, basically. So this is going to ground. I'm going to change the color to black. Yes, I'm going to delete this connection because I don't like to connect on my device, so I'm going to go this way. So it's just to make my connection very nice. So I'm going to change this color to black. So changing this to black, and the positive side, I'm going to be connecting my buzzer to digital pin 9. So this is digital pin 9, and so we're going to digital pin 9. So yes, this connection is done. Now we need the push button as an emergency call, right? To press down when there's an emergency. So if once there's an indicator, the buzzer is already making beeping sound, or something is happening and all that. So the push button basically is to tap to call a healthcare personnel. So when you press the push button, just like you have like an app on your phone, and you press the emergency call, you tap on the emergency button, it reaches out, you can easily use it to call. So we use the internal Arduino, the Arduino's internal pull-up resistor, because it has that. So no external resistor is actually needed for the push button. So we're going to get the push button, which is already right here. and we're going to put our push button. So basically one side, you can use one side for negative and one side for positive, right? So the negative part, we're going to just take this to ground. Basically I'm going to connect this to my GND, and let me just change this color to black. And the other end, I'm going to be connecting the other end to digital pin 7. So digital pin 7. So digital pin 7. So I'm going to do this connection. So yes, so digital pin 7. So now the sensor we're going to add, now we're going to add the potentiometer, which is for the patient vital simulator. So it's, you just turn it, it's like a knob, you just turn. So it's going to be checking the patient's vital simulator. It's a patient vital simulator, that's what it represents. All right, so let's get a potentiometer. So the potentiometer has 3 pins, like so one is ground, so this goes directly to ground. So potentiometer makes it very easy. The signal goes straight to the analog pin, which is analog pin O. So we're going to take this to analog pin 0. We have 6 analog pin from A0 to A5, and we have 14 analog digital pins from digital pin 0 to digital pin 13. While the VCC is the voltage, number of voltage, which is the 5 volts, it requires 5 voltage to power up. So that is for the potentiometer. So we're done with the potentiometer. So now we need the LDR, which is the room lightning. This forms as a voltage divider basically. So in this case, it's just going to be reading because LDR is a sensor that it's basically used to sense light. It's a light sensor. It's called the light density resistor, or some people call it photoresistor. So this is it's the real light LDR actually has 2 pins, but we also have some LDR sensors that has 3 pins. The one right here on Wokwi actually has 3 pins, so we're going to be using that. So we're going to get the photoresistor, which is the LDR sensor. So let's place it somewhere here, basically. So we're going to be connecting. We do require, if you're connecting for doing the physical connection, you actually need a 10K resistor, which will connect to the AO and the AO to the ground. So I'm going to change this to 10K. So I'm going to still connect this. So I'm going to connect this here, right here. So let me put it here. So let me put this. So AO connects to this, basically. And AO connects to this, and it then takes this to A1 on the Arduino Uno. So this is just, yes, so GND goes to GND. So but if it was just real, like we're doing the physical connection, I'm going to connect to AO and the other end will go to the GND. So that's the way the connection will. But since we don't have that, so let's just do this now. So let's just do a connection. This goes to GND. Okay, so and VCC, of course, it goes to 5 volts. We're going to take this to 5 volts. Yes, so we're done with all our connections. So basically, like I said, this is a smart patient observation system. That's what this is, right? And the problem, what we're trying to solve is a lot of times in the healthcare, in hospitals, healthcare professionals often monitor many patients at the same time, and manually checking patients, can be quite difficult. I'm speaking from someone whose mom is a nurse. It is very difficult. It is tedious, especially when we have lots of patients, especially when you go to like general hospital in Nigeria. It can be very tedious. It can be very tiring. So in developed countries or very good healthcare, modern healthcare, they basically they rely on monitoring system that just continuously collects patient information, notify the healthcare workers whenever attention is required. So they don't have to be there. So you just have a system. So it's not all hospitals, especially in the rural areas or community health centers, we don't have that system. So we're trying to make life easier so that even the community health centers can actually have this technology in there. It helps them to to put a lot of things together, to just do other things, attend to other patients at the same time. So just get, like, there's this button put beside the patient, you just tap on it. These are some of the things that just helps them and makes life easy for them at the end of the day. So the Arduino Uno is the healthcare monitoring controller. The LDR is the patient's room lighting condition that just changes. The potentiometer serves as the patient vital reading. The push button is the emergency call button. The LED stands for the patient status indicator, switches the emergency alarm. The buzzer is emergency alarm. And of course, we're going to create a dashboard using an AI tool, which will now serve as the healthcare monitor. So the nurse or the healthcare practitioner just has that at their end. And so this is basically how it's going to work. So let me explain the system work again. So the Arduino itself, it continuously monitors the room lighting. It's the patient vitals and the emergency button. Then the Arduino checks whether the room has become too dark, right? If the room is too dark, which is why the presence of the LDR is there. The simulated patient vital exceeds a safe threshold. The emergency button is pressed automatically. It just clicks automatically or pressed automatically. So if there is if depending on the situation, right, the system automatically activates visual or audible alert. If the situation is normal, if there's nothing, no alerts, if the low room lighting, the LED turns on. If there's high simulated vital readings, the LED turns on. If there's emergency button is pressed, the LEDs and the buzzer is activated. So the dashboard, which the healthcare practitioner will be seeing to display the patient status, the observation alerts, the room condition, emergency notifications. If the patient presses the emergency button, the healthcare practitioner is notified and attends to the patient, right? So that is basically all for the system. So let us go to the coding part. Of course, we've done the design, so it's now for us to write our instructions. So I'll start with my comments so that anyone reading this would understand what this project is about. So once I'll always tell people, start with your simulations. Once the simulation is working, you will have no problem with a real life project working. So let's just write a comment. So the comment is for anyone seeing this to understand what the project is about. So we're creating a smart patient observation system, and this is for, yes, that's what we're doing. So now it's time for us to define. We're going to define our pins. Now we've done the simulation, we need to tell Arduino ID that, oh, I assigned this pin to this pin, this is what I placed here. So I'm going to make it a constant. It's not changing anytime soon, right? It's going to be constant. So constants. So it's I always advise to do camel casing when it comes to naming your variable. So this is the name of my variable LED pin. So I'm assigning it to pin 8, which is the number there. So const. Int stands for integer, which is whole numbers, either positive or negative. So buzzer pin, I'm going to use this for buzzer pin. I connected the buzzer to pin 9, do not forget. So it's time for the button pin. So button pin, I connected this to pin 7. And now the potentiometer port pin, I connected this to AO. And the LDR pin, I connected this to A1. Always terminate at the end of the day. So now it's time for us to set up to indicate the LED is an output device or components. The button is an input. So these are some of the things you need to let. And the buzzer is an output because it's emitting sound. You need to let Arduino know. So we're going to be defining the pin mode now. So pin mode, LED pin is output, and I'm going to terminate this. Pin mode, buzzer pin is output, and I'm going to terminate. Pin mode is input, so I decided to use the input pullout. or you can use input pull. So because I want to see some things on my serial monitor, like I just want to see things right here. Since I don't have like the physical components, I want some serial display at the bottom part, so I see different levels. So I'm going to be using my serial print. Serial, so I need to do the, so I'm going to use my serial begin to tell you that it started. So this is for serial monitor basically. This is 96. I'm using Arduino Uno, so it's 96. So yes, we're done with that part. I'm going to be writing every instructions in the loop. So what I want to happen should be in the loop. Now I'm going to create a variable for the vitals, and it's going to be reading the potentiometer. Remember, the potentiometer is for vitals to indicate to check our vitals. So let's create a variable called vital, and we're going to tell it analog read. Should read the potentiometer pin. Should read the potentiometer pin, and we're going to, for the LDR, which is to read the room lights, analog read as well. It's going to read the LDR pin. The termination, the semicolon there is just like at the stage you're ending a sentence, you put a full stop. So that's the same thing I'm literally doing. So bool emergency. This is the boolean value, only accepts the real value. So digital read. Now this is for the button itself. So we need to read the button. So button pin. So you can only accept either low, high, true, false. That's what boolean means. So it can only accept either one of these value, 1 or 2. That's what boolean basically is. So we're assigning it to low, right? So now we're going to create another for warning. It indicates warning. So the warning should be declared false, either true or false. So now if there's low room lighting, so probably while the patient is in the room, the light is low. So this is just like a basic project, right? So other things can be added to it. You can actually create this to be more, expand this to be much more than this. You can add temperature to sense temperature. Yeah, the other sensors, basically the smoke sensor, the gas sensor, the other ones that you can actually add. But for now, for just this project, it's just something very basic, something very simple, just using the LDR. So if light is less than 400, so if the light's coming into the room, it's less than 400, so the warning would be true, right? So let's close that part and let's move on. So that is all for the, and if we have a high patient, so for the high patients, for high patient vital simulation, so we're going to do that for high patient vital simulation. So we're going to be telling vital is greater than 700, then what should happen? Warning will be true. So, of course, once the vital has been checked and it's greater than, then warnings will be true. So now, let's do another condition. So this is for emergency. If there's an emergency, so what should happen when there's an emergency? So we need our LED to come up. So the LED pin, so when you have high, it means the pin should come up. So that's basically what that means, right? The buzzer also the same thing. The buzzer will come up as well. And if that is not the case, if it's just a warning. So what should happen if it's just a warning? The LED pin would also come up, but this time around, buzzer would remain low. Okay, so else, if that is not the case, so both the LED and the buzzer will be off, will go off. So our LED pin would not be, would be like, well, we're not, it's not going to come up. So because it's a stable situation, and the buzzer at the same time would also not come up. So this is the situation. So one will have a stable situation, nothing is coming up, no indicator, nothing. So now we have a serial pin. Remember I said that we're going to be using speed at the bottom of this. So we're going to use serial print. There's print line, but we're going to use serial print. So say vitals. So it's going to display our vitals. So let's put this in double quotation. These are called strings. If you want, so you have to put them in double quotation strings. So it has to be in double quotation. Then serial dot print again. So what should we print? Should print out the vitals. Want our vitals to be printed. Then we also want the lights. Serial does print. I'm going to put like a comma in between. It prints the lights. Okay. Lights. So then serial does print. You can actually use print line, but I've decided to use print. So they both work, right? So able to work. I could use that as well. So this is then another serial. This is built on C++, so it is case sensitive, and it's very important that you ensure that while you're doing you always put that into consideration. So for the emergency, so now for emergency, I want to use the print line. So that's what I said. So I'm gonna print out emergency, and I'm gonna delay. Delay means to wait. So let's make it wait for 200 seconds, and that's basically the end of the instructions. That's it. So if we run this simulation, so let me just save my work. If I run the simulations, then we'll see what would happen. So let's click to run, and let's see what happens. So yes, it's good. So I have like an error, and so yes, let's see why we have error. Cons, because we do not indicate the data type, and that's why that's error. So it's very important to always indicate your data type of whatever it is you're doing. You need to indicate if it's a float value, if it's an integer, and these are some of the things that these are some of the things that we know. Okay, yes. So this is working right now. Can you see? It's showing vital 0, lights 400, and emergency nothing. So what happens when I turn the potentiometer? So let's stop this and let me zoom out a bit. I want everyone to be able to see, so that, and let's run again this so that we can see this. Okay, so if I press the push button, did you notice something? There's something I wanted to tell you. So you can see that the buzzer here is not emitting sound, and it's because on Wokwi it uses a passive buzzer, so you cannot write digital writes. You cannot use digital writes. It's only for active buzzer. So instead of digital writes, we use tune. So I'm going to change this instruction to tune, and I'm going to indicate how high. So this is even much better. So I'm going to use 2000, and no tune means nothing shouldn't say anything. I think 2000 is a lot. No, it shouldn't emit any sound. So let me just make these changes. These are some of the things that a lot of people do not note, that when you're writing instruction for passive buzzers. You can't use the same thing. So it's passive buzzer uses tune and no tune, and it's also very good when you want to create like project house, you want to play like different sound, right? So this is it right here, and so did you see? You can actually hear the sound. So when there's no emergency, it's nothing is happening. So the moment I change the potentiometer, in the light is changing, the vitals is changing. What if I switch the LDR, which indicates the number of lights? So this, can you see? Vitals remain stable, lights keeps changing, and anytime I press the emergency button, there's an emergency and there's a beeping sound. And if I want like the tune to, there should be you want to have like different tunes over time, so you could do delay 50 and create another tune. So buzzer pin, and you want us like this. It just creates like this just creates like this tunes, and that's it basically. So let's try and see it work again. You see that the sound is different. So that's basically it. That's just the difference. So yes, so we have come to the end of our project. See you next time. Bye.